A very good morning. Um, at this hour, I would like to speak on a very boring topic, uh, which is maths, and also a particular expansion series which I was not able to fathom its meaning in the 11th standard. But now, when I realize that it has its wild applicability and you just can't walk away but to accept and embrace the Taylor expansion series in order to understand the geothermal gradient in Indian geological context. So here I begin. I am an aspiring geologist working in the field of CBM in Indian coniferous basin, where the intercalation of coal is mainly with shale and sandstone with portion of mudstone and metamorphic basement equivalent rocks of granitic origin at its peaks. Now, the geothermal gradient, if we apply with the concept of linearity, it's going to be apparently not that right, say at a particular depth of 100 meter. It has been a practice to consider a wide thumb rule that 35 degrees Celsius per kilometer would be the increase per every 1 kilometer. The increase would be 35 degrees Celsius, and more the basin is near to a tectonic belt, the range seems to be higher. Without taking such assumption, how we can derive the particular temperature, say at a point depth x beyond the depth profile, considering 0 as the surface depth. So the popular is the Taylor series expansion, and what I discovered is that there are going to be various iterations from the surface till the desired depth that you are coming into, with decrease in the temperature value at times, and then suddenly taking a sharp exponential growth and contributing to the massive figure on the temperature at a depth. Now coming to the Indian basin context, Jharia coalfield, Raniganj coalfield, they are the storehouse of good amount of methane, and also Jharia and Raniganj coalfield has a good thermal regime. So this is quite obvious that the geothermal gradient would be quite higher. Now temperature plays a pivotal role in describing the amount of volume that the coal strata holds at a particular depth. So we would be going into the derivative of the function of the depth and considering the temperature starting at 0 degree Celsius, at 0 degree, considering the temperature of surface, measuring the surface temperature at a particular depth, and finding out the derivatives at each depth until the depth that we are looking for. So this will let's consider the coal seems to be the row 1, row 2, row 3, row 4, and let's say the depth has been up to 600 meter, so till row 6, and surface to be the row 0. So we have to find the derivative, the first derivative, the second derivative, the third derivative until we reach the row 6. So this is how the Taylor expansion series helps in deciphering the geothermal gradient and find out the desired value of the geothermal regime, the temperature, how it varies at each locales of depth until we reach the borehole closure depth and the bottommost coal seam. That's all from me today about the geothermal gradient. Thank you.